Okay, shh. Learning outcome 18. When we combine resistors in series, the total resistance is the sum of the individual resistances, i.e. what you just found there, RT is equal to R1 plus R2 plus R3. Okay, for 19 then, it's just based on combining the last two rules. So when analysing circuits, with more than one resistor, we need to combine learning outcomes 17 and 18. And that's best to demonstrate just using the example we've just done together. Calculate the current in this circuit. Okay, our circuit's got a cell. And two resistors, 5 ohms and 7 ohms. And it was a 6-volt cell. So when we're analysing this question, we're writing down what we know. We know that V is 6 volts. We know that R1 is 5 ohms. R2 is 7 ohms. And we're being asked I. So the first step we did was the voltage that we're given is the total voltage for the whole circuit. So we need to work out the total resistance to go with that. So we added those two together. And we've got 12 ohms. Then that is our resistance that we need to solve to find the current. So the formula we're using is V equals IR. 6 equals I times the 12 that we just worked out. Swap sides to get I on the left-hand side. Divide both sides by 12 because I want to know what I is on its own, not when it's multiplied by 12. So the opposite of multiplying by 12 is divide by 12. And then I can get my calculator out and do the 6 divided by 12. And that gives me the final answer. Right, so example 2. In this circuit, I'm going to make it a 12-volt battery. And I've got a 4 ohm resistor and a 2 ohm resistor. And the question is, calculate the voltage across the 2 ohm resistor. So remember, we talk about a voltage across something and a current through something.
Does that say 12 volts?
To solve this for the 2 ohm resistor, well, I know its resistance is 2 ohms. I don't know its voltage, that's what I'm being asked to work out. But to use the formula V equals I times R, I need to know the current as well. It doesn't tell me in the question what the current is through the 2 ohm resistor, but it does give me enough information to work out what the current in the circuit is. So I'm going to start this question by looking at the whole circuit, and then I'm going to look at the 2 ohm resistor once I've looked at the whole circuit. So kind of within my answers, I need to put wee kind of headings to make it clear which bit of the circuit I'm talking about at any particular time. So first of all, for the whole circuit, what I know for the whole circuit is that V is 12 volts. I can work out that RT equals R1 plus R2. Remember doing these? So it's quite simple. The total resistance is 6 ohms. I just get that by adding them up. And then I'm going to look at and try and work out, well, what is the current in the whole circuit? Because in a series circuit, the current's the same everywhere. So if I know what it is for the whole circuit, I know what it is for just the 2 ohm resistor. So now from the whole circuit, I can do V equals IR. I can plug in that V is 12. I don't know I, so I'll leave that as an I, remember. And I can plug in that R is 6. And now it's just a rearranging thing. I'll put in all the steps. Okay, just in case you find rearranging difficult. And then I'll divide both sides by 6. Because that cancels out the times 6 and the divided by 6 cancel out. And I get my calculator out and I get the current is 2 amps. Now I can look at the 2 ohm resistor on its own. And for the 2 ohm resistor, I can now use that same current, because in a series circuit, the current is the same everywhere. So I take my answer from the first part, use that as my current. I also know that for the 2 ohm resistor, well, fairly obviously the resistance is 2 ohms, and I'm being asked V. So once again, I'm going to use the formula V equals I times R. V is my unknown, so I'll leave that. And now I know that 2 is the current and 2 is the resistance. So I can work out that the voltage across the 2 ohm resistor is 4 volts. And that's how you get to the final answer. Underline your final answer just to make it clear.